Okay, so we are starting with inclined plane. A very, very interesting topic. We are starting with inclined plane. Now, in case of inclined plane, whenever you are keeping a body on an inclined plane, children, please remember, suppose this is a body. Now, what we are trying to do, that in this case, a body is kept on an inclined plane. This is theta. And always your mg will be acting in the downward direction. Mg will be acting in the downward direction. Now, what you have to do, first step, is always try to resolve the mg into components. That means, what you will do, you will take two axes like this. One, along this inclined plane, along the inclined plane, and another perpendicular to the inclined plane. So I have taken two axes like this, because ultimately the motion of the body will be along the inclined plane. So naturally I have to take these two axes. Now what is happening over here, if I take this to be 90 degree, this angle will be 90 minus theta, therefore this angle will be theta. So very, very important is that this mg is inclined at an angle theta with the vertical axis. So I think you will agree, this is the vertical axis, this is your mg, and this is your theta. So mg is inclined at an angle theta with the vertical axis. Now what I will do, I already taught you children, whenever you are having a force like this, if this is your theta, so that means always this component will be f cos theta and this component will be f sin theta, right? We have done this already. So similarly over here, this is your mg. So this component of mg will be mg cos theta, and this component of mg will be equal to mg sin theta. So what we are getting, our step one is that you will resolve mg into two components. That means whenever you are drawing an inclined plane problem, please remember children, your first duty is that you put the block like this, you draw mg, then you resolve it into component. This will be your mg cos theta and this will be your mg sin theta. So you have resolved mg into two components. Am I clear to everybody? So this is mg sin theta component. That means this particular sin theta component will be actually, that means what is happening over here, whenever you are keeping a body on a horizontal plane like this, the total downward force will be equal to mg. But when you are keeping a body in an inclined plane, so its component will be resolved. One is the mg cos theta component, another is the mg sin theta component. Now from here what you can get, so this is the total concept of inclined plane. Whenever you are having an inclined plane, you have to actually keep this into account. Now let me give you some problems on inclined plane that will be very, very helpful for you. I will be gradually shifting on the problems, and that means the level of problems I will increase gradually. Now another important thing I like to draw your attention over here, this is your reaction, and this reaction is also known as normal reaction. This reaction is also known as normal reaction. And remember one thing children, in an inclined plane diagram, your normal reaction is always is equal to mg cos theta. Very, very important. So your normal reaction is always equal to mg cos theta. So this is another very, very important thing I like to tell you. So normal reaction is also equal to mg cos theta. Now I'll give you one problem, everybody, because gradually I'll do the problems. Write down. First, write down. We are doing some problems on inclined plane now. Write down. A body is sliding down an inclined plane. Body is sliding down an inclined plane. Down an inclined plane, having angle of inclination theta. Having angle of inclination theta. Calculate its acceleration. This is the ekdam step one problem I am giving. Calculate the acceleration. Calculate the acceleration. A body is sliding down an inclined plane, having an angle of inclination theta. Calculate the acceleration. So first and foremost, I've already taught you like this. You draw an inclined plane. This will be your mg. This will be your mg cos theta. And this will be your mg sin theta. So now what will happen? This is your acceleration, this direction, because the body is sliding down. So your ma will be acting in the opposite direction. So this will be your reaction. So now if I draw the free body diagram of this body, so this is your mg sin theta, and this is equal to ma. So what you are getting? ma equal to mg sin theta. M and M gets cancelled. Therefore, A equal to G sin theta. So one important assumption we have taken over here, that the body is actually, what is happening? The body is actually, and the inclined plane is actually frictionless, that is smooth. We are at this moment not considering any frictional concept. We are absolutely assuming the body to be, the surface to be frictionless. I hope it is clear to everybody. So I will change the problem a bit now. Let us move on to the second question. Number 2. Write down. Calculate the force required. Calculate the force required. Calculate the force required to move a body. Calculate the force required to move a body up an inclined plane. Calculate the force required to move a body up an inclined plane with an acceleration A. Up an inclined plane with an acceleration A. So let me now draw this figure for you. Once again, I am drawing the inclined plane. Absolutely easy. What will be your first step? Draw a block. Then second step, draw mg. Third step, draw mg cos theta. Fourth step, draw mg sin theta. So this is the minimum requirement of any inclined plane. You should not make any mistake. Now the next part comes, very, very interesting part. That is what you are trying to do. We are trying to pull the body up. So I have to apply a force in this direction, such that the body undergoes an acceleration in the upward direction, right? So according to the problem, the body is undergoing an acceleration, right? So what is happening? As the body is undergoing an acceleration in this upward direction, so body, there will be a ma in the opposite direction, right? So what will be the free body diagram of this body? This will be F, this will be ma, and this will be mg sin theta. So from here, what you get? F equal to ma plus mg sin theta. So force required will be equal to F equal to ma plus mg sin theta. I hope it is clear to everybody. So this is another type problem I have done for inclined plane. Okay. So you can find out over here, that is F equal to ma and that is equal MA plus mg sine theta. This is the force required. So this is the second type of the problem. Now another problem I like to draw, that is third type. Write down this problem. Here it is. This is the third problem of inclined plane. See, over here, there is a body of mass M2. Children, I am purposely giving you all the types of question in terms of M1, M2 and theta, so that we don't lose time in doing the calculation. But in your exam, normally you will get all the problems based upon calculations. So you please be very particular about doing the calculation without doing any mistake. Fine. So let us move on to the next part. So suppose what is happening, this is an inclined plane on a M2 is kept, and over here we have kept a pulley, and this is M1. This is theta. Now, according to the question, M1 is greater than M2. So they have given M1 is greater than M2. Find number one, acceleration of the blocks. Acceleration of the blocks. Find the acceleration of the blocks. Number one, find the acceleration of the blocks. Acceleration. And number two, tension. Number two, tension. So here we have to find out this. Now again, one thing you have to understand, this surface, write down, assume the surface to be smooth. Write down, assume the surface to be smooth. That is very, very important. Assume the surface to be smooth. Okay. So let us now start with this question. So over here, what is happening? This is your theta. So once again, I draw this because you know that this is your M2G. This is your M2G cos theta. And this is your M2G sine theta. And this will be your M1A, M1G, sorry. Now, since M1 is greater than M2, I think you will agree one thing, that the entire system will be accelerating. This will be going down and this will be going up. And these are the tensions. So now gradually we'll try to write down, just we'll try to put the MA and get the equations. Very, very easy. Now just put the MA. Now this is going upward, so MA will be downward. So this will be your M2A. Now this is going downward and this will be going upward, M1A. So now what is happening? This is tension T. This is equal to M2G sine theta, and this is equal to M2A. So this is the free body diagram for M2. And for M1, this is your M1G. This is your tension. And this is your M1A. Now equate. Here, T equal to M2A plus M2G sine theta. This is your first equation. This will be equal to T plus M1A equal to M1G. Therefore, T equal to M1G minus M1A. This is your tension. Now put this equation in the value, this value over here in this tension T. So what you shall get? You shall get M1G minus M1A equal to M2A plus M2G sine theta. So what you are getting total? M1G minus m2g sine theta is equal to m2 plus m1 into a. So therefore you are getting a equal to m1 minus m2 sine theta whole g divided by m1 plus m2. So this is your acceleration. So this is the acceleration. Now how to find out t? You can replace this a in any of the equation. So t will be equal to m1g minus m1, and you put the value of the entire a that you have got from here, children. So what you will be getting? I think you can solve this easily on your own. Just solve it. I will be getting t equal to m1g minus m1a, m1 minus m2 sine theta divided by m1 plus m2. Now you can take m1g common from here. So we'll be getting 1 minus m1 m2 sine theta divided by m1 plus m2. So just do the calculation now, nothing else. So tension T will be equal to m1g divided by m1 plus m2. So it will be m1 plus m2 minus m1 plus m2 sine theta. So plus m1 minus m1 gets cancelled. So you take the m2 common from here. So the final answer will be m1 m2g divided by m1 plus m2 into 1 plus sine theta. So this is your tension. So everybody please note down this. This is a very, very important sum. So this is equal to m1 m2g into 1 plus sine theta by m1 plus m2.